Hi students, today we are going to see about Introduction to NDT. Myself, Sathish, Assistant Professor, Mechanical Department at Akshay College of Engineering and Technology. Introduction to NDT. NDT stands for Non-Destructive Testing. NDT is a wide group of analysis technique used in science and technology industry to evaluate the properties of material, component or system without causing damage. The term non-destructive examination NDE, non-destructive inspection NDI and non-destructive evaluation NDE are also commonly used to describe this technology because NDT does not permanently alter the article being inspected. It is a highly valuable technique that can save both money and time in product evaluation, troubleshoot and research. Non-destructive testing is the use of non-inventions technique to determine the integrity of a material, component or structure or qualitatively measures some characteristic of an object. It is the testing of materials for surface or internal flaws or metallurgical condition without interfering in any way with the integrity of the material or its suitability for service. That is, inspect or measure without doing harm. 6 most common NDT methods are there: visual, liquid penetrant, magnetic, ultrasonic, eddy current and then X-ray. In visual inspection, we can able to see visual inspection is the simplest, fastest and most widely used non-destructive testing method. Visual inspection is carried out with the naked eye or using some optical aid such as mirror, magnifying glasses or microscope. Seeing is believing and the art of seeing is the visual inspection technique. Visual testing requires adequate illumination of the test surface and proper eyesight of the tester. The test specimen is illustrated and the test surface is observed and examined. Whatever required, the optical aids such as mirror, magnifying glass, microscope, video camera and computer vision systems can be employed. Applications of visual inspection: checking the surface condition of the component, checking of alignment of muting surface, checking of shape of the component, checking for evidence of leaking, checking for internal side defects. Liquid penetrant inspection. Liquid penetrant method is an effective method of detecting surface defects in metal and other non-porous material surfaces. It detects flaws that are open to the surface, example cracks, seams, lack of bond, porosity, cold shut, etc. Liquid penetrant test is that the liquid penetrants are drawn into the surface flaws such as cracks or porosities by capillary action. Then the developer material in conjunction with the visual inspection reveals the surface flaws. Application of liquid penetrant inspection. Inspection of tools and dies, inspection of tank, vessel, reactor, piping, and pumps in the chemical, petrochemical, food, paper, and processing industries. Inspection of diesel locomotive, truck, automobile parts such as axle, wheel, gears, crankshaft, cylinder blocks, etc. Now we are seeing magnetic particle inspection. Magnetic particle testing is used for testing of materials which can be easily magnetized. This method is capable of detecting surface and subsurface flaws such as cracks and inclusions. This method can be used for testing of ferromagnetic materials such as iron, steel, nickel, and cobalt alloy. The non-ferrous materials such as aluminum, magnesium, copper, lead, tin, and titanium, and ferrous but non-ferromagnetic austenitic stainless steel cannot be inspected using this method. It is a relatively simple, inexpensive, and rapid technique. It is free from any restrictions as to size, shape, composition, and heat treatment of ferromagnetic specimen. Application of magnetic particle inspection. Inspection of fan and blowers in thermal power plant, inspection of weld cracks, inspection of connecting rod, underwater inspection such as offshore structural weld, pipeline inspection, and shape structures, etc. Ultrasonic testing. Ultrasonic testing is one of the popular non-destructive testing methods that uses the sound energy to determine the integrity of these testing objects. In ultrasonic testing, the very short range high frequency ultrasonic wave, whose range lies between 0.5 to 20 MHz, are used for detection of surface and subsurface flaws in the testing objects. In ultrasonic inspection, an ultrasonic beam travels through the testing object and internal defects such as cracks interrupts the beam and deflects back a portion of the ultrasonic energy. The amplitude of the energy reflected and the time required for return indicate the presence and locations of any flaws in the testing object. Application of ultrasonic testing. Inspection of large casting and forging for internal soundlessness before carrying out expensive machining operation. Inspection of moving strip or plate for lamination as regarded its thickness. Routine inspection of locomotive axles and wheel pins for fatigue cracks. Inspection of rails for bolt hole breaks without dismantling rail end assemblies, etc. Eddy current testing. Eddy current testing is an electromagnetic non-destructive testing technique. This method can be used only on all electrically conducting materials. This eddy current testing is also known as inductive testing. The eddy current testing works on the basis of electromagnetic induction. In this method, eddy current are induced in a testing object by bringing it closer to an alternating current carrying coil, which is shown in the figure. This eddy current are normally parallel to the coil winding. The defects in the test object impinge and change the direction of eddy current and causes changes in the electromagnetic field. This changes affects the inspection coil, the voltage of which is monitored to determine the presence of defect. Image illustrates the effect of a crack on a pattern of a eddy current flow in a plate. In this plate travels a length of inspection of the coil as shown in figure. Application of eddy current testing. Detection and measurement of flaws in steering mechanism, airplane landing gears, engine parts, reactor and steam generator turbine, aircraft wheels, aircraft wing structures, turbine blades, etc. Radiographic inspection or X-ray. Radiography testing is one of the most important, versatile and widely accepted of all the non-destructive examination methods. The radiographic testing method is commonly used for the detection of internal flaws such as cracks and porosity in many different materials and configurations. In radiography testing, X-ray or gamma ray is used to determine the internal soundness of the material. Hence, it is also called as X-ray or gamma ray testing. Radiographic inspection employs the same principles and techniques as those of the medical X-rays. In this picture, we can able to see radiography uses an X-ray or gamma ray as a source of radiation which passes through the testing object and is captured or filmed or digital device. After processing the film, an image of varying density is obtained. Using the image, possible imperfections are identified through the density charges. Application of radiography inspection. Detection of internal discontinuous such as shrinkage, cracks and porosity in casting. Verification of integrity of internal components. Determination of the quality of welded sections and pipes. Identification of the extent of corrosion. Inspection of variety of non-metallic particles. Locating discontinuous in fabricated structures, assemblies, etc. Comparison between destructive and non-destructive testing. Purpose. It is carried to find properties and behavior of specimen under different load. Non-destructive testing. It is used to find properties of materials and to find out defects. Specimen is damaged during test. In non-destructive testing, specimen is not damaged during test. Defects. In destructive testing, defects cannot be found using destructive testing. In non-destructive testing, defects are found using NDT. Cost-wise, more costly in destructive testing, less costly in non-destructive testing. Example of destructive testing: bending test, tensile test, compression test, impact test, etc. In non-destructive testing, ultrasonic testing, liquid dye penetrant method, eddy current testing, etc. Importance of NDT. NDT increases the safety and reliability of the product during operation. It decreases the cost of the product by reducing scrap and conserving material, labor and energy. It enhances the reputation of the manufacturer as a product of a quality goods. All of the above factors boost the sales of the product, which brings more economical benefit for the manufacturer. NDT is also used widely for routine or periodic determination of quality of the plants and structures during service. This not only increases the safety of the operation but also eliminates any focused shutdowns of the plants. Scope of NDT. Non-destructive testing is a descriptive term used for the examination of material and component in such a way that allows materials to be examined without changing or destroying their usefulness. NDT or NDE can be used to find size and location surface and subsurface flaws and defects. NDT plays a crucial role in everyday life and is necessary to assure safety and reliability. Typical examples are found in aircraft, spacecraft, motor vehicle, pipeline, bridges, trains, power station, refineries, buildings, and oil platforms, which are all inspected using NDT. NDT is a quality assurance management tool which can give impressive result when used correctly. It requires an understanding of the various methods available, their capabilities and limitations, knowledge of the relevance standards and specification for performing the test. NDT is used typically for the following reason: accident prevention and to reduce cost, to improve product reliability, to determine acceptance to a given requirement, to give information on repair criteria. Difficulties in NDT. However, lack of skilled operator, an aging workforce, and cost conscious users are key challenges faced by the non destructive testing market. Through development in infrastructure and power generation, have incrementally increased demand for new operators, but shortage of supply and shrinking budget continues to. Future progress in NDT. 3D characterization. Ultrasound is the ideal vehicle for exploring the local response of a composite structure to stress and map this across the whole 3D structure. Mechanical model using NDT data. Recent development in X-ray CT and ultrasonic 3D characterization of the components composition offers the potential for the greater understanding of the effects on structural integrity of material variations such as in plane fiber waveline, out of plane ply wrinkling, and 3D variations in fiber volume fractions or porosity. Economic aspects of NDT. It is highly economical compared to other methods. Products can be reused. Rejection rate is less. That's all for today's section. Thanks for listening, students.